Lesson 2.8. We are going over two variable inequalities today. This is Algebra 1 review. Not saying you remember it all, but this is Algebra 1 review. So, two variable inequalities. We're going to jump right in. See what you guys remember. What is the graph of y greater than 3x minus 1? The hint I will give you is to start by thinking about the graph y equals 3x minus 1. How do we graph y equals 3x minus 1?
So you start at -1, and then you would go, it would end up being like 3 over 1. You would think of it as 3 over 1, so you go up 3 over 1.
Okay.
Smart.
I followed it. So what, and this is all because this is in what form? This is, okay, so y equals mx plus b. We know the slope, as she said, is 3, which as a fraction is 3 over 1. The y-intercept is -1. So when you go to graph that, you do start by making a point at -1, which means you're going to go down 1 and make your first point. From that, we're going to rise 3, run 1. Officially, 2 points is enough, right? I like to do an overabundance of points, just to help keep my line straighter and more accurate. So I'm going to go up 3 over 1 a couple of times. You can also reverse it and go down 3, left 1. Now, because we are graphing inequalities, you officially have 2 questions to ask yourself to continue this problem. Do we know them? Yeah. Go ahead, grab a ruler if you want it.
They're right here if you didn't know where they were. I didn't know that.
So first question, what kind of line are you using to connect these dots?
A straight line. Not straight, it's a dotted line. A dashed line? A dashed.
Okay, so remember you have a choice when you're doing an inequality. It all is a line, okay? I'm not going to argue that. But you can either make it a normal solid line or a dotted or dashed line, whatever you call it. A lot of people today have been saying dotted line. I usually say dashed line, a broken line, right? So which one is it? Is it solid or is it dashed? Why is it dashed? Okay. Because my original one was just a greater than symbol. It is a dashed line. So when you connect it, dashed line, please. Dotted line, whatever you want to call it. There is my dashed line. So that's one question you ask yourself on all these problems today. The second question, do you know what the second question is? Yeah, where do we shade? Your choice, your options are always above or below. Do we shade above or below? Because it's always in reference to y, which is a vertical axis.
So below because it's negative. That's not right.
It's above.
Why above?
Because you said below and it was wrong.
That's a good point.
Logic. Seriously, why above? And other than the fact that below was wrong.
Is it because the slope is positive? Is it because it's the opposite of negative?
What sign is this? A greater than sign.
Because it's greater than the negative.
Greater than. Greater than tells you to shade above. Less than would tell you to shade below.
Miss Broad's class is making so much more sense in my head. I'm having flashbacks of her times. like, oh yeah, that's what that was.
Okay. Are we okay with shading above? Shading above because it is greater than. Now, on this particular problem, where is above?
The left side.
The leftish side. Now, is that saying that above is always left? No, it depends on the slant of the line, right? So in this case, it's going to be the left, but above is what we're doing here. And it's above because it's greater than. Now, first of all, some of you may need to write this down in your notes. Have we forgotten which sign is which? Okay, because you can no longer think about it eats the bigger number. Because do we always have numbers? No. So you have to know which sign is which. The less than sign to me looks like the L because it faces the same direction as an L, or a less than sign points left where the numbers are smaller. A greater than sign looks like such. It points right where the numbers are greater. So if you need to add that in your notes because you're struggling at the moment with that, please do so. I'm not saying you have to add it, but it might be helpful for some of you.
I always think about it like it eats the bigger numbers, but then I got that wrong on my test, and so I got scared.
Well, and here's the deal. I mean, we have y greater than. So it's eating the y. How did you know y is bigger? You know, you have to understand.
Because it always is the L.
Yeah.
I just remember the L now.
Okay. Now, question?
Sorry, I was just gonna ask, does the dash line apply for both the greater and the less than signs?
But it's just equal to.
Yeah. Okay, so what I want to do before we move on to the second problem is I'm going to make us a little cheat sheet off to the side so you have everything condensed about what does what. Okay? But that's exactly what I was going to do. So the first question we're going to ask ourselves, or the first cheat sheet I'm going to make, so to speak, a dashed line versus a solid line. When do I do a dashed line versus when do I do a solid line? So what symbols are you going to see when it's supposed to be a dashed line? Okay, so signs that do not have the equal to part, correct? So a dashed line is going to happen when it's either less than or greater than. So when does a solid line happen? So when the equal to does exist, so less than or equal to, greater than or equal to. And again, maybe you don't need this cheat sheet. Maybe you got it all straight in your head, but doesn't hurt. The other thing I'm going to note is when we shade above versus below. So what kind of signs tell me to shade above? Okay, anything that involves greater than. So greater than equal to. So what kind of signs tell me to shade below? Less than or equal to. Does that help? You got everything condensed, right?
Yeah.
I mean, if you think about it, it makes sense. Above is greater than, below is less than. Dashed lines are not equal to, solid lines are equal to. That's the generalized version. Before we go back to our second example, I want to do a kind of add-on question over here, a sample question. That is me asking, is the ordered pair 2, 3 a solution of y greater than 3x minus 1? And I throw this in because you're going to see some of this in homework. Is 2, 3 a solution of y greater than 3x minus 1? Abby, you shook your head yes.
I had to shake my head no. I was like, yeah,
You're shaking your head no now.
no, and I was like, well, maybe, but I didn't say no.
Do you have a reason for your no answer?
Because the line doesn't go across.
Okay. So what I'll say here, and how did you decide that doesn't go across that line? Okay. So you realize it's the same line over here? Is that what you're saying? I don't know if you guys realize this or not. This is the same problem over here. Now, y greater than 3x minus 1. If it said y equals 3x minus 1, I'd want to know, is 2, 3 on the line? But greater than. What makes it true if it's greater than? Okay, we'll talk about that here in a moment. But if you have a graph, how do we know if 2, 3 is a solution? It's going to be a solution if it's in the shaded area. Is 2, 3 in the shaded area? Just barely, but it's not. So by looking at the graph, it's not in the shaded area, so I know that this is not a solution. That's one way to tell. Now, Zephanie, you said you plugged it in, meaning in the ordered pair 2, 3, x is 2 and y is 3, yes? So if you don't have a graph, this is your best plan, and that is plug the values in. So putting in 3 for y greater than 3 times 2 minus 1. 3 times 2 is 6. 6 minus 1 is 5. Is 3 greater than 5? No. And so, same answer, right? You can plug it in, find it out that way, or look at the graph and see if it's in the shading or not. Questions on that? You can. Yeah, if you're looking at the graph, you're saying no because it's not in the shaded region. If you're looking at plugging in, it's no because 3 is not greater than 5. Yes, by all means, if you want to put a reason, because that will make sense when you look at this back, when you're looking at your notes later for homework help. Yes. That is the reason I explain sometimes. Okay, you ready to try example 2? You guys start example 2 while I answer the phone. Hello? He is. I will send him down. Okay, bye. Mrs. Fields would like to see you. It shouldn't take too long is what I got. So.
Part 2. I thought it was going to be tracked on. No, they're double for today, please.
Okay, guys. You guys are supposed to be doing part B while I answer the phone. Or have you already done part B?
I wrote out the equation.
Okay, so good to recognize, first of all, that when we're graphing this, we want to think y equals 3/4 x minus 1. We need to acknowledge that slope is 3/4. And the y-intercept is -1. Y equals mx plus b, right? So what are you doing first?
Go down 1.
We're going to go down 1. Put our y-intercept. Okay, my phrase for slope. Rise 3, run 4.
Then you can make extra points if you want to.
And then Mrs. Sargent is going to make extra points.
I'm going to go down 3. Let it go.
So,
I could be a math teacher. I probably wouldn't teach them much, but I could do.
okay, however many points you want to make there, obviously minimum 2.
And then you're going to think about your sign and what kind of line you need.
Okay.
Yeah, think
Solid line or dashed line?
Solid.
Why does it say solid line?
Because it's greater than or equal to sign. And in our cheat sheet, it says solid line.
I think of it as like the line underneath fills in the little dashes.
There you go. Yep.
I do too.
Anytime that you have the equal to, so the line underneath, it is a solid line. So just a normal line, so to speak, right? And
And it will be shaded below.
so you're now asking yourself if we're going to shade above or below. This sign is what type of sign that matters? Less than. Anytime you have a less than type sign, we're going to shade below. Did it again.
Yeah, I saw that and I wrote it down and then I was just looking at it and I was like, why are we shaping that way? Whoops.
Did I do it wrong?
Okay. We are shading below. I did that earlier today. I wrote the wrong sign in there too. I don't know. So we are shading below because it's a less than sign. Is below pretty obvious on this one?
Yeah.
Okay. If you guys don't mind, I'm going to skip C if you're feeling confident with this stuff. However, before I move on to problem 2, I want to do 2 special case examples here. I'm going to do those off to the right. So I'm going to come over here. The first special case example I'm going to do is the inequality y less than 3. In other words, my special case examples are, what if there's just a y or just an x? Okay, yeah, so remember, when it's just an x or just a y, those are my vertical and horizontal lines. They are not diagonal lines. Y equals 3. Which kind of line is that?
It's horizontal because it switches with X.
Okay, so the y equals 3, it cuts through the y-axis at 3. If you prefer something, a different way of thinking, think about an XY chart. In an XY chart, y would always have to be 3. So you can fill in numbers, and so it would be like 0, 3, 1, 3, 2, 3.
Why did I never think about that? I always made it so much more complicated.
I try, it's for whatever reason, this is a hard thing to remember, whether it's a horizontal or vertical line. I don't know why, but it just is a hard thing for everyone to remember. And so I'm trying to give you techniques. You pick the technique you like. Some of you like to think, oh, y equals 3, XY chart. Some of you like to think, oh, well, it crosses the y-axis at 3. And so that means it's going to be parallel to the x-axis, right?
Can I do my things on my chart if I like use different points in the bottom? Like on the chart that we're using for C since we're not doing C?
Yeah. I don't care if you use C.
Just mark out the equation.
Okay. So, all of that to say, how do I graph this now? Or how do I finish this off? Question 1. This is a dashed line because it is less than and not equal to. Question 2. Shade above or below. This is less than, so we're going to be going below.
What do we do for a vertical if we have to shade above?
Don't steal my thunder. As in, guess where I'm going next, Abby? No, it's a very valid question. It's good. I'm giving you a hard time, Abby. Don't be offended.
I give her a hard time every single day.
Okay. No, it is exactly the question you need to ask. You're thinking ahead. You're just stealing my thunder because that's my next question.
The answer is I don't know.
The answer is we'll talk about it momentarily. Okay, my other made-up example is x greater than or equal to 2. Now, x greater than or equal to 2. This is like graphing the line x equals 2. So what kind of line is x equals 2? It's a vertical line. If you struggle with, it crosses through the x-axis at 2, could you think about an xy chart here? Yeah, all of your x's are what? 2. So you can think 2, 0, 2, 1, 2, 2. So now, this is a vertical line. What kind of line am I using to connect my dots? This is solid because it's greater than or equal to. So this is a solid vertical line. And the question, do we shade? Okay, so what do I always say? I only want to hear you ask, because this is 99% of the time it works, above or below. So what are you going to answer me? Do we shade above or below? Officially, according to our sign, we're going to say above. However, can we shade above on an exact vertical line? No. So what do we need to think instead, since I can't really do above on a vertical line? Left or right. And what makes sense for greater than? Greater than should be right, because it's where, like if you're shading on a number line, where would you go greater than? You would go to the right. So this is the one time you get away with, instead of saying above or below, you say left or right, but only on the vertical lines.
So would left technically be
The equivalent's the same below. Yeah, it's when your sign is less than. Does that make sense?
Is that always or no?
Mm-hmm. Yeah, and it's just like if you're on a number line. If you're on a number line, if it's a less than sign, you go left. If it's greater than sign, you go right. Okay. We got what we need there? So get what you need, and then we are going to move down into problem 2. Okay. Yeah, I was specifically waiting for you because I knew I was giving you the opportunity to get caught up here.
Why don't you just walk in and you finish before I do?
Okay. Problem 2. What do you guys notice about problem 2? What do these have? Absolute value. Have we done absolute value recently? What does an absolute value graph look like?
A V with a pointy point.
Okay, so
Just a V.
these graphs are going to be V's because we have absolute value in them. Now, first thing I want you to do when you're graphing is make sure y is by itself. Make sure it's like y equals. In this first example, I have y minus 1. So to get y by itself, we're going to add 1. If you add 1 on the left, you add 1 on the right. So then I'm going to have y less than absolute value of x plus 2 plus 1. Notice I did not add that 1 into the absolute value. It has to stay outside.
That looks like the equation to get on.
Okay, so now, when you think about this, we graphed equations like this yesterday, right?
Yes.
Y equals absolute value of x plus 2 plus 1. Where does this V move?
You're going to go up 1 and to the left.
Okay. The +2 in the absolute value is left or right, opposite the sign. So that is a left 2. The +1 outside is up or down with the sign, so that is an up 1. So I can go, my vertex would normally be at 0, 0. I move left 2, up 1. Officially, if you have to state a vertex, your vertex is now at -2, 1.
Okay.
Okay. When we draw the sides for the V's, how are we going to draw these sides for the V's?
The right side and
The what?
the right branch and then reflects the left.
Okay. And how do I draw the right branch?
Make a
Okay. Easiest thing to do, guys, do we have anything in front of the absolute value giving me a slope? No. So that just means you go up 1 over 1 because it's a slope of 1. That's the right branch. The left branch is just the reflection of it. Now, this was an inequality, yes? Same 2 questions you've been asking yourselves all day. First question. What type of line? Stephanie says a dashed line. Do you like it?
Yes.
It's not equal to. It's not equal to, so it is a dashed line. Or in this case, it's a dashed V. I mean, I say dashed line, but I assume you understand dashed V. And then you're going to ask yourself, where are we going to shape? What are my options?
Up and down.
Above or below?
Or shape below.
Do we agree with below? It's less than. So less than is shade below. Where is below on this graph?
Well, is it underneath the left and right branches?
Okay, underneath the left and right branches. In this case, it is pretty much outside of the V, right?
Yeah.
Everything outside of the V.
Yeah.
That is your below.
If you make your lines go all the way up, you know where it goes.
Should look something like that. Okay, let's try example B then. So, what's the first thing I need to do on this one? Take the 4 over. We want y to be by itself, so I'm going to add 4 over. Y greater than or equal to absolute value of x plus 2 plus 4. Okay, what kind of pieces can you tell me? Okay. Plus 2 inside the absolute value, left to right, opposite the sign. So left 2. The 4 at the end is going to be up 4. Okay, so officially my vertex will be negative 2, 4, because I'm moving left 2, up 4. In front of my absolute value, there's no number other than the invisible 1. So a slope of 1 means up 1 over 1, up 1 over 1. Two questions.
What's your line?
What kind of line? Solid or dashed? Why is it solid? Not because it's greater than, because it's equal to. All because it's equal to. So solid line, because it's equal to. And final question, where do we shade? Above, because it's greater than. Where is above on this graph? Okay, in this case, it's inside the V. Okay, on the back side, do what you need on the front side. On the back side, we're only doing the top two. I'm not worried about the bottom two, so we just need to get the top two. You can. I just want you guys to realize, don't go home thinking, oh, she didn't finish the notes. We don't have to have the homework done. Yes, I am going to finish the notes. We only have 2 examples left. So we're reversing what we're doing now. Last time they gave me an inequality, we had to graph it. This time they give me the graph. We have to gather the information for an inequality. So let's identify some information. Let's start with, we can do a bunch of different things. A vertex. Can you tell me the vertex? She says 3, -2. Okay.
3, -2.
Okay. If the vertex is 3, -2, where is that going to go into my equation? Do you remember from yesterday? Yeah. So 3 is my H, and -2 is my K. And let me remind you, the equation we're trying to fill in. Y equals A times X minus H plus K. Does that sound familiar? So right now we know H and K. And you can if you want. I mean, where did this graph go? This graph moved right 3, down 2. That's how I got to that vertex, isn't it? Okay. Let's talk about the slope. I know it's a little hard to tell here, but what's that slope doing? Up 1/1? It is. Okay. So a slope of 1, what is that telling me? That is my A value, which basically means we just don't have to have anything out there. And now we need to think about what kind of line and what kind of shading. Help me decide my sign. What kind of shading is this? Above. And so if it's above, it has to be either greater than or equal to. What kind of line? It's a dashed line, dotted line. What's that mean?
Greater than.
It is greater than because it's not equal to. Okay, can you do it? Y is greater than.
Some interruptions. Have your attention for
Slope of
today and now.
1, so I'm going to leave it blank.
Chloe Haggerty in the
X
school office.
minus
This Friday
3
is that day for a $1 donation. You can wear a hat. All proceeds will
plus
go to
-2, so
Friday.
minus 2.
There will be no spell bowl practice tomorrow. If you want to join the AP Art Club, please see Allie Reed for information. World War II Club, the New Orleans Parent Info Night will be September 30th from 6 to 7 in the high school cafeteria. Seniors, when you have your senior quote ready, tell, text, or email Mallory Herring. The TC's Talent Art Awards and Pie event will take place at the start of homeroom tomorrow in the cafeteria. All staff and students are welcome to attend. The lucky teachers to receive a pie in their face, Mr. McDermott, Mr. Wilson, Mrs. Sargent, Mrs. Holman, and Mr. Huntley. Chat's Cafe will be open tomorrow. There will be a blood drive on the 18th. Eat a good breakfast and stay hydrated if you are giving blood. See Mr. Kevin to sign up. Freshman class shirts. If you'd like to purchase a class shirt, write your check and make them out to Tri Central. Take it to Mr. Kevin. Make sure you're doing your handling and care of laptops, your TC responsibilities policy. Purdue University will have a representative here during homeroom this Friday. Make sure and sign up in the guidance office if you are interested in attending. If you missed the wrestling call-out meeting yesterday, please see Mr. Wilson. Sophomores, your class shirt orders are due September 12th to Dr. Austin. That is tomorrow. There will be IUK parent night, on Thursday, September 12th from 6:30. We'll start at 6:30 to whenever at IUK. There'll be a FAFSA night here at Tri Central on October 3rd from 6 to 7:30. Very informative meeting. Seniors, you should plan to attend. Any seniors wanting to attend the National College Fair need to have your permission slips turned into the guidance office by this Friday, September 13th. Athletics tonight, we have middle school volleyball at home against Elwood at 6. Good luck to the girls. Thank you and have a great evening.
Okay, let's do this last one real quick. Where does this V move? In other words, vertex. Over 4, and that is a left 4, up 3. And so as a vertex, that is -4, 3. Those are my H and K. What about a slope on this one? What's going on that right branch? Down 1, right 1, which is a -1. What is that -1 value going to be? That's going to be my A value. And where is my shading on this one? Shading is above. So above means it's going to be some type of greater than. It's, what is it? Not equal to, so just greater than. Y greater than negative of x minus -4
Seniors,
plus
if
3.
you have not voted for the class shirt, you need to report this for non-true at this time. Seniors.
Okay, so what I did say here, I said x minus -4. What did I write? Plus 4. Notice my -1 outside. I didn't actually write the -1. I just put a negative out front to represent that. Lesson 2.8 in Math Excel is your homework. Get it done tonight, and we will talk NWA tomorrow.